All right, we are going to continue our discussion on area models. I just want you to recall from yesterday that when we want to know how much an object has moved, we can find the area under its curve, and that will tell it curve, and that will tell us how much the object has moved. If that area under the curve happens to be really irregular, then we divided it into narrower and narrower rectangles and found the area of each one of those rectangles and added it up. Okay, just in case you don't remember, when you start to do more and more and more rectangles and the number of rectangles starts to approach infinity, then you arrive at what's called a definite integral, okay? And there's some big fancy dancy notation right here, but this is kind of what I want you to pay attention to. This little symbol right here that you see is called an integral. This basically gives you the left side of your x value. Excuse me. This gives you your right side of your x value. And then what's going to happen is you're going to have a function in here, okay? And I'll show you what it means in just a minute here. So this is an integral. Basically, it's asking me to find the area under the curve that's above the x-axis, and it's important to recognize that it's above the x-axis, between when x is 0 and x is 4. Okay, so what you're going to do is you're going to graph this function right here, which I have done right here. Okay, so this is the function 2t plus 1. I'm wanting to find the area underneath the curve between when x is 0 and when x is 4. Okay, here's where x is 0 right here, so I'm going to go up until I hit the curve. Here's where x is 4. I'm going to go up till I hit the curve. And I want to find the area of this region in here. Luckily, I can do this very accurately because it happens to be a trapezoidal shaped object. And so I can just find the area of the trapezoid and that'll answer that question. And I actually don't even need to divide this one into like little rectangles, although I could. It's actually going to be more accurate by following my trapezoid formula, which is what I'm going to do. Okay, so what you need to know then is this. Obviously, this is one side to that trapezoid. This is the other key length on the trapezoid, and this is the another key length on the trapezoid. Okay, here's what you need to know. I need to know this distance right here. And by the way, the area of a trapezoid, I should tell you this, the area of a trapezoid is 1/2 the average, or is the average of the bases. So it's 1/2 of base 1 plus base 2 times the height. Your bases are your two sides that are parallel to each other, just to remind you of that. Okay, so this is one base right here. We're going to call this base 1. It is 2. If you didn't know that, this is what you would do. Along this line, your x value is 0. My function is 2t plus 1. So if I wanted to know my y value, I would just go 2 times 0 plus 1. Okay, well, 2 times 0 plus 1 gives me 1. But that doesn't seem right, does it? Um, I don't think this is graphed right. It's not. It should be 2t plus 2. That's why this is not graphed right. Okay? Sorry, it's 2t plus 2. Anyways, 2 times 0 plus 2. And obviously you're going to get the point 0, 2. Okay, so you know that this is too high. You can count also. All right, over here, sorry for the confusion. This right here is base 2. Again, my x value is 4. When I plug 4 in, I can have 2 times 4, which is 8, plus 2 gives me 10. So it's 10 high. Okay, so that means my base 2 is 10. All right, this is my height. I'm going from 0 to 4 seconds, and so I know that my height is 4. Then I will just plug everything into my trapezoid formula over here. So I will have 1/2 my base 1, which is 2, my base 2, which is 10, and my height, which is 4. So this becomes 1/2 times 12 times 4, or 6 times 4, which is 24. Okay, so I have an area of 24 underneath that curve, which means that my object moves 24 feet miles, whatever the units would be, if I was talking about a moving object. Okay. Here's another one, just so that you can see what happens here. This is the function 1/2 x plus 1. So I graphed it. Hopefully I graphed it accurately this time, which I did. It's the function 1/2 x plus 1. And I'm finding the area under the curve from 2 until 5. So I'm finding this area underneath here. And again, it's a trapezoid. Okay, this is your base 1, which is 2. This is your base 2, which is, it looks like it's 3.5, but if you want to find it out for sure, accurately, at that point, your x value is 5. If you plug 5 into your function, then you would have 1/2 times 5 plus 1, which does give me 3.5. Okay, so your base 2 is 3.5 because your y value at that point is 3.5. And then this interval right here is 3 seconds. So again, you can do a trapezoid. Trapezoid is 1/2 of base 1 plus base 2 times your height. So 1/2 of 2 plus 3.5 times my height, which is 3. When I figure all of that out, I get an area of 8.25. All right. And lastly, this one we're actually putting it into context. Suppose a ball rolls down a ramp so that its velocity is always 2t. So this is your function that you're working with, feet per second. How far does it fall during the first 3 seconds? So basically that means from 0 to 3 seconds, okay? You could write this as an integral that would look like this. Your time starts at 0 seconds. It goes to 3 seconds. Your function is 2t. This will be just dt, which just means as time changes. If you did x, you do dx. If you did y, you do dy, whatever. Okay? So I graphed the line 2t right here. 2t has a y-intercept of 0 and a slope of 2, so that's what it looks like. I want to find the area from 0 to 3 seconds. So that's this area right in here, underneath, above the x-axis, but underneath the curve. Okay? You can see that that's a triangle. The base of my triangle is 3. My height would be 2 times 3 because my function is 2t. My time is 3 seconds. 2 times 3 is 6. And the area of triangles have the base times height. So 1/2, 3 times 6 would be 9. Okay, so my object moved 9, and I should go back up here and get units. 9 feet, because it's in feet per second, so it moved 9 feet, and I should label that. Okay, and that's this lesson.